All right, so physics people will know what I'm talking about. But like when we're talking about variation, we trying to describe how one quantity varies with respect to the other one. That's what we're talking about. So variation. Let me give you an example, right? Mm, and this is an example of Hooke's law. Now, when we're doing variation, it have two types of variation. As you're going to see, it's gonna have directly proportional, and does anybody know the other type of proportionality?
Indirectly proportional.
Yeah, yeah, directly proportional. Or we say inversely proportional as well. All right, so the first one we're going to look at is directly proportional. When you hear the word directly proportional, what do you guys think of? If nothing comes to mind, tell me. But if something comes to mind, say. So directly proportional. What comes to mind? I was talking about an example of Hooke's law. Physics people. Anybody could tell me what Hooke's law is? Anybody know physics people? I found five physics people here.
Yeah,
I found five physics people
yes,
here.
sir.
Talk to my guys. Do you know what directly proportional means in terms of Hooke's law?
Yes, sir. Force is equals to AE.
Right.
Well,
F
F is equal to K,
right? What does K stand for?
a constant.
Right? It's the spring constant. And E would be a what?
EE,
Yeah, what would E be for? The extension,
that
sir.
would be the extension.
Good. Now, I know to have some people in this class that does not do physics. I understand how people here that don't do physics, but I like to think that this is not as hard as it may look. It's very intuitive. So essentially for directly proportional relationships, if one quantity increases, the other quantity would what? It's directly proportional. So if one quantity goes up, what happens to the other quantity?
Will
So
go up to.
yes, because they're directly proportional. So if one quantity goes up or increases, so if one quantity increases, so does the other quantity. But by how much? That's the question, but by how much? And that would be represented by the constant K. So if one quantity increases, so does the other quantity. The constant of proportionality K, the constant of proportionality K tells us by how much. So let me give an example of a directly proportional relationship. So example, Hooke's law. So I want somebody to talk to me that not doing physics. Have anybody in here that don't do physics?
Me, sir.
Okay. So Hannah, Hooke's law has to do with the relationship between force and extension for a spring. Now, Hannah, if you apply a force to a spring, what will happen to the spring?
It would exert the same force.
Nah, I feel like you're overthinking it. Like, okay, if you take a spring, right, and you hold it in your hand and you pull it, you apply a force. What would happen? So yeah, you have a spring on your hand, and you grab the spring on one end, and you grab the spring on the other end, and you exert a force on it. So like you pull it. What happened to the spring?
Or it would expand, like get bigger.
Yeah, it would expand, it get bigger. And we call that extend. So this example goes like this. So, the force applied to a spring is directly proportional to the what? Tell me, Hannah. So the more force they apply to a spring, what happened to the spring? The more force they apply to a spring, or what happened? Or what happened as they applied
The
more
more
force?
it would, the more it would extend.
Exactly, the more it will extend. So can't you see that the more force you apply, the greater the extension? That makes sense, right?
Yes.
So the more force you apply, the greater the extension. So you can see that's a directly proportional relationship because when one goes up, the other one goes up as well. So the force applied to a spring is directly proportional to the extension. And somebody that doing physics finishes off me. Like if you were to write the proper definition for Hooke's law, what would I say after this? I would say granted that what?
That the spring doesn't pass its limit.
Exactly. And you have to be specific. You'd say granted that the spring does not pass its elastic limit. So Hannah, that makes sense, right? Because if you apply too much force to a spring, isn't it going to remain stretched and it's not going to go back to its original shape? If you apply too much force to a spring, you ever like take out a spring from a pen and like pull it too hard and you break the spring? You know what I'm talking about or not? Any of you ever do that?
Yes.
Any of you ever make like toy guns using your pen? Like that's peak childhood. That's peak child. I don't know if any of you ever do that. I feel like Kelani will do that. Yeah, I am from Kelani, but
You mean
like,
like
yeah,
yeah,
yeah.
sorry, my volume was down.
That's okay. Like you break a pen, you take apart your pen, and you try to make like a toy gun, quote unquote. You ever do that
Um
before now? Like to
no,
like to like
not
make
like
it.
a toy gun, but like
Hmm.
what I do was like I take the spring and I basically like I I so weird, it was some weird, but I just take the spring and I put it in my tongue and I just kinda like suck on
What?
the spring
What?
so that it will stick on my tongue.
What? Anybody ever do
So
that?
I used to do that too. It used to like feel good too. I don't know.
What
Yeah,
DJ?
Christian gonna know what I'm talking about.
Christian would have. And it wanted weird Christian gonna know about them thing. That's anybody ever do that with a spring before? I don't think I ever seen anybody do that before. Well, I'm not a judge.
I
But
said it in this way, you probably just can't remember.
nah, I don't, I don't remember doing that. So Hannah, this makes sense. And if you were to draw the graph of force versus extension for this relationship, what kind of relationship do you think it'd be? Do you think it'd be a curve, a line? What do you think it'd be? If you had to guess.
A line.
I would agree it'd be a line. Because as force increases, what also increases? Okay, maybe it might be a bit hard to see. So like let me give you some really like some exact values. So let's just say when we right call this 5, call this 10. So Hannah, tell me something, right? When I apply a force of 5 newtons to the spring, from the graph, it looks like the extension is what?
2.
It looks like the extension is 2 centimeters, right? So I'm gonna just put some units here. So just like our physics class almost. So someone they do that do in physics, or like they benefits in like twice. All right, and Hannah, when I apply a force of 10 newtons to the spring, it looks like it looks as though the extension is what?
4 centimeters.
So by applying twice the force, it extended by how much time?
By 2 times.
You're sure you understand that?
Yes, sir.
Okay, if you don't understand, just tell me. But from this graph, can you see that as we apply more force, the extension is increasing in a linear way? So if all I had to say, it looks as though when I increase the force by 2 times, the extension is increasing by, if you had to say. Please real quiet. I don't know why it's so quiet for. Everybody all right? Are you okay?
So I real tired. So for the past 2 days, so I probably get about like 10 hours combined.
That is still a lot
Sleep.
of sleep. That's still a lot of sleep. Considering that is exam time, right? Considering that is exam time. Yeah. I see Nikolai here, Nikolai Mirage. Talk to him, I'm gonna feel him.
Yes, sir.
Right, so Nikolai, have you ever done variation in maths? Or nah?
Never.
Never?
Nah,
Okay.
first time I seen.
Well, yes, so I think you would have do Hooke's law in physics. Yeah or no?
Yeah, we do all that one, but we never really touch plenty.
Okay, in the form for class, I believe I would have do Hooke's law at some point in time. But anyways, Nikolai, I'm trying to explain variation here. And there are two types of variation, directly proportional and inversely proportional. So when we're talking about direct proportionality, we say like if one quantity increasing, so does the other one. But by how much? So Nikolai, can you imagine that if you have a spring and you apply a force to a spring, what happens to it? Tell me, Nikolai, if you have a spring and you pull it with some force, what happens to the spring?
They go extend.
More force you apply, what happens? If you apply more force, what happens?
More force that apply, go keep extending.
Exactly until it reaches its elastic limit. So would you describe that as a directly proportional relationship?
Yeah, they're directly proportional.
Exactly, because and it's like if I increase force, it directly affects an extension. That make logical sense, right?
Yeah.
Everybody understand that or no? Do we understand the premise of directly proportional relationships? Like if one increases, the other one would increase as well.
Yes.
All right. Good. So I want you to understand that when we're dealing with proportionality, especially directly proportional, all directly proportional graphs are going to be what? Could somebody tell me? From this graph here, this graph was a what kind of graph? A quadratic graph, a linear graph? What kind of graph was this? Serena, if you had to say, what kind of graph is this?
A linear graph.
Correct, a linear graph. So all directly proportional, all directly proportional graphs are linear. And you're probably wondering, how would I express this in variation notation? Well, I'll show you. So I would say that the force is directly proportional to the extension. So could everybody see this symbol over here? The weird looking symbol that looks like a fish without a tail? Well, it look like he's missing a part of his tail. Looking like he's missing part of his tail. But this symbol over here. Could any of you guess what that symbol means? Yeah, no, maybe, potentially. Yeah.
So is it directly proportional?
Yes, this symbol over here tells us that the force is directly proportional to the extension. So I'll make a little note about it. I don't know why I live so quiet today, boy. Why I live being so quiet for, boy? I don't know how to take it. It's like a heartbreak kind of thing. So this means that force is directly proportional to what? Tell me, Nikolai. Force is directly proportional to what? Nikolai, Mirage? Tell me. Force is directly proportional to what?
The extension.
Yeah, the extension. And do you understand that this is a symbol here that means directly proportional? Yes or no?
Yeah.
Okay. Cool. I hope everybody is with me. So this over here means directly proportional. So, Serena. No, I called Serena already. Sienna. So we figured that force is directly proportional to extension, but do we know by how much? Do we know exactly how they're related?
Is it the same amount of force you exert on the spring would be the same amount the extension would be?
It can't say that for sure. It can't say that for sure. Let me explain why. Okay, talk to my right people in the class. Let me just say I apply a force of 100 newtons. Which spring would extend more? The spring in a car suspension or the spring from a pin? So I apply the same force. I'll tell me which one would extend more? The one from a car or the one from a pin? Why we so quiet for? Olio?
You want from a car?
What? No, 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 no. No, no. Olio ever see the spring from a car for a car suspension or no? No? Okay, that's like a big heavy spring. That's okay. Let me ask you like a logical question. If the spring for your car was very weak, and every bump you feel, would I feel like death? Just imagine that if the spring in your car suspension was weak, every bump you go over, the car would like go up and go down violently. But because the spring is really powerful, it absorbs a lot of the energy. So I'll ask back the question again. I think all I need to see this is a bit alarming. Let me show you something. All right, so watch this, right? Which one do you think would would be easier to extend? That spring or this spring? Spring from suspension. Nikolai Mirage, which one do you think would extend more? The spring from the pen or the spring from the suspension in a car?
The spring from the pen.
Exactly. You ever try to push or pull the spring from a suspension?
Them thing don't move at all.
Them thing don't move at
Stagnant.
all. So that is very stiff. I'm talking about spring stiffness. So Hannah, I think it was you that said that the spring from the car would be able to extend easier. A way to compare, okay. Maybe you need to see like a better diagram to see the scale we're talking about. Right, so Hannah, you see that red spring over there? Hannah, let me
Yes,
just,
sir.
and you seeing that, right? You seeing somebody hand over there. You can imagine how big that spring is.
Yes.
Yeah or no?
Yes, sir.
All the people in class, do you think it'll be easy to extend that spring or compress that spring? Look at the size of it. Serena, you think that spring will be easy to like pull or like compress?
No, sir.
No, look at the size of the thing. There's a man hand there. Hey, what you think about this logically now? Compared to like the spring from a pen. The spring from a pen is like minute. And you can easily pull that.
No, sir.
So Serena, the point I'm trying to make is different springs are going to have different levels of stiffness. So you can't just say that when you apply a force, the extension would increase by the same amount. No, you can't say that. So you need to actually figure out K or the spring constant. So I'm going to show you how to do that. All right, so Nikolai McLeod, let me know if you're there.
Yes, sir.
So Nikolai, do you understand what I'm saying? Like different springs would have different levels of stiffness. So not all springs, if you apply a force, they go extend by the same amount. Does that make logical sense?
Yes, sir.
Right. So the next line, I would have to introduce the constant of proportionality. So I'd say F is equal to KE. Because we know that they're related, you know. We know that they are related. It's just we don't know by how much. We don't know that. So this symbol over here is the proportional symbol. And up in the next line, you're going to replace the proportional symbol with the equal to K. And the reason for that is because, like I said, Nikolai, and we need to know how force is related to extension.
Yes, sir.
Good. So Nikolai, from this graph over here, we could figure out what K is. Do you want to tell me how we could figure out for K?
It will be F over E.
K will be F over E. Can we take points from the graph here?
Yes, sir.
Yeah, we can. Now, Nikolai, you should be seeing this, right? This is like our physics problem. You have F versus E, so F on the y-axis and E on the x-axis. So if you wanted to find for Q, wouldn't you just find a gradient?
Yes, sir.
I'm not sure if all is seeing that, but like if you find for the gradient of that line, you would get K. All right, somebody that's not doing physics. Okay, Hannah, you're not doing physics, right?
No, sir.
Right. But Hannah, do you know what the equation of a line is per chance? Equation of a line.
No, sir.
Nah, okay, does anybody know what the equation of a line is?
Y equals mx plus c.
Yeah, y is equal to mx plus c. So when you compare y is equal to mx plus c to this, it looks as though y is what? What is y? What is y? If all I had to say, what is y? Right.
F.
Well, you could see that for yourself that f is on the y-axis. Yeah or no?
Yeah.
Okay. What is m? M is k. All right. So that means that the gradients will give me k. What is x? What is x represented by?
E.
And can you see that E is on the x-axis? Yes or no? I'm going to follow seeing that.
Yes, sir.
Good. And well, notice that we don't really have a plus C. But if I write plus 0, you can see for yourself that C is 0. Furthermore, when you look at this graph looks as though it's passing through the what? The what? What do I call that point over there? 0, 0. That's the what?
Origin.
Yeah, it looks as though it passes through the origin. So that will be plus 0. So, Hannah, can you clearly see that F is equal to KE is in the form of a linear equation? So on the y-axis, we have F because YF, and on the x-axis, you see an extension, right? So if you wanted to find for the spring constant or the constant of proportionality, K, you just have to find a gradient for this graph. That's all. Are you seeing what I'm talking about? With it being a line or no? If you're not seeing that, just talk to me. I'll try to re-explain it. Yeah, getting quiet. I don't know how to take quiet. But Hannah, the point is if you want to find for K, you need to find a gradient. Hannah, do you know how to find the gradient of a line?
I can't remember.
Okay. No problem. So to find the gradient of a line, you need 2 points that are on the line itself. You need 2 points on the line. When you look at this, do we have 2 points on the line? Tell me, Hannah, do we have 2 points on the line?
Yes, yeah.
Yeah, we have 2 points on the line. Could you tell me the coordinate of this first point?
2, 5. Oh, well, 5, 2.
Now, when you're reading off a point, you have to tell me the x value first. And so like this is this is what's on the x-axis, and well, this is what's really on the y-axis. So you have to tell me the x value first, which is 2. 2 is the x value, and 5 is on the y-axis. So 2, 5. Read off the next point for me.
4, 10.
4, 10. Good. So when you're finding the gradient is simply the change in y over the change in x. And you're probably saying, so what do you mean by that? Well, I mean y2 minus y1 all over x2 minus x1. That is what I mean. And so, Hannah, when you look at these 2 points, you have 2 points, don't you not? I mean, if you see now, I had 2 points. 2 points.
Yes, sir.
All right, so the first point, it really doesn't matter which one you call the first point, but if it was up to you, Hannah, which one you'd call the first point? If you were to say, which one would you call the first point?
2, 5.
All right, so you call that the first point, so x1, y1. And what do you think I'm going to call 410 then? And the first point is x1, y1. What do you think I'm going to call my second point?
X2, Y2.
Correct. Wait, just to make sure we're on the same page, right? Did you know that a coordinate comprises of an x value first and a y value? Let me know if you knew that.
Yes, sir.
Okay, bets. So you understand why I'm saying x1, y1 and why I'm saying x2, y2. Right, Nikolai Mirage. Let me know if you're
Yep.
with me so far. Nikolai, remember how to find gradients on that? Can I hear Nikolai? Regina, let me know if you're with me.
Yes, sir.
Okay, Regina, you know how to find gradients?
Yes, sir.
Okay, cool. So let's continue, right, Hannah? So we know that the y2 value is 10, and what's the y1 value?
Oh, 5.
Right, so I'll say 10 minus 5. What is the x2 value?
4.
And the x1 value is?
2.
So what is 10 minus 5?
5.
And 4 minus 2 is?
2.
Nice. And 5 over 2 is 2.5, yeah?
Yes, sir.
Good. And this is what k is. So k will be equal to 2.5. And if you're wondering, well, sir, but how you know that? How you know that? Well, what kind of graph is this? Somebody tell me fast. What kind of graph is that? What kind of graph is that? A line or a quadratic?
Linear.
It's a linear graph. And all linear graphs is being form what? All linear graphs is being what form? Somebody talk to me. It's being what form?
Directly proportional.
Yeah. All linear graphs are inherently directly proportional, correct? But what I was really wanted to hear is y is equal to mx plus c. is what I wanted to hear. Y is equal to mx plus c. So, Hannah, if you compare f is equal to ke to y is equal to mx plus c, you realize that y is force, m is going to give you gradient, and x is going to give you extension. And well, we don't have anything. So the y-intercept is just 0, 0. And I think you can see that because when you look at the graph, the line passes through what? What does the line pass through? Tell me, Hannah, it passes through what?
0, 0.
Correct, which is the origin. So it makes sense that the y-intercept is 0. So just by comparing it to this, you'd see that if you want to find the k value, which is the constant of proportionality, you'd have to find the gradient. Now, when we found gradient, what did we find it to be?
2.5.
And when you're comparing f is equal to ke to y is equal to mx plus c, you saw that the gradient was what? What does the gradient represent? What did m represent?
The gradient.
Yeah, m represented the gradient, but what did it correspond to?
Oh, K.
K. Now I'll write it down over here, right? Because again, you're probably wondering what is k? K is the constant of proportionality. So we just found k to be what? Salma, Hannah, we just found k to be what?
2.5.
Good. So if I were to write my relationship, I now know what k is. So I could say that f is equal to what?
2.5.
Right? 2.5 by?
E.
Good. 2.5 by e. Now, I know some of you guys are literally very, very confused and you're saying, well, I don't understand how this and this link together. You know, I don't understand. Hannah, you don't understand? I'm just curious. You don't understand?
So I understand.
But I'm just gonna go over this just to make sure they understand, right? So you're probably wondering, well, I want to see proof. I'll show you proof. I'm gonna show you proof that it works. So, Alia, from the graph, right? When the force was 5 newtons, what was the extension? Somebody tell me, what was the extension? Somebody
2
want,
centimeters.
all right. Now, according to our relationship was F is equal to 2.5 E, yeah? That's what our relationship was. That's what we found it to be. F is equal to 2.5 E. And so let me show you something, Hannah. So, Hannah, if I were to apply a force of 5 newtons, I'd replace F for what? If I apply a force of 5 newtons, what would I replace F for? So tell me, Hannah, if you're applying a force of 5 newtons, what is force then? What is the value for force then if you're applying a force of 5 newtons?
Five.
Yeah, a lot of these things are a lot simpler than you think. If I tell you you're applying a force of 5 newtons, and at that point, F is 5. So I would say F is equal, F, which is 5, would be equal to 2.5 E. And according to our graph, Hannah, we know that when you apply a force of 5 newtons with the extension, we know that the extension should be what? What the extension supposed to be?
2 centimeters.
It is supposed to be 2 centimeters. So here's what I'm trying to say. I'm trying to say if you plug in 5 as force and you make extension the subject, you are supposed to get 2. So that's what we're trying to prove. We're trying to see if our relationship works. So F is equal to 2.5 E. So Hannah, if I were to make extension the subject to the formula, what would I do on both sides?
Divide.
I would divide by what on both sides? I want to find for E. I want to find for E. So what do I have to do on both sides? I want to find for E.
Divide by 5.
No, if I divide by 5, that's not going to help me. I want to find for E. Watch, if I divide by 5, I'm going to end up with 5. The 5 and the 5 will cancel off. And 2.5 over 5 is a half. So 1 is equal to a half E. That didn't really help me much. If I want to find for E, then I want E to be the only term on one side. So tell me, Hannah, if E is on the right-hand side, I want you to look at E. Is E the only thing that's on the right-hand side there? Is it the only thing?
Yes, sir.
Nah, E is being multiplied by what? E being multiplied by?
2.5.
E is being multiplied by 2.5. So if you wanted to get rid of the 2.5, what do you think you'd have to do?
Divide by 2.5.
Good. You'd have to do
Divide
the
2.5.
opposite, which is divide by 2.5. Now you're gonna put 5 over 2.5. What is 5 over 2.5? Somebody tell me, what is 5 over 2.5? 5 over 2.5. Yes, 5 over 2.5 is 2. Aha! Did our relationship work? Somebody in class tell me, did our relationship work here? Did it work?
Yes.
Yes, Akira, it did work. Now, Hannah, I'm not sure if you're seeing it. Are you seeing it? Yes or no? Be brutally honest. Are you seeing what I'm trying to say or no?
Yes, sir.
All right, then Hannah, explain it to me. What did I just prove? I just proved what? What did I prove? See if you can explain that to me. Okay, I'm not hearing Hannah, but anybody in class think they could explain what I was trying to prove here? Any of the 4 and 5 people? I think I could explain what I was trying to prove here.
It was constant to force. No, when you substitute for K, it would have been equal to the force, which was 5, and you multiply the 2.5 by 2.
Not quite.
Like,
No, not quite. So, Nikolai, I was trying to prove if our relationship here was true. That's what I was trying to prove. So we would have came up with F is equal to 2.5 by E. So here's what I'm saying, Nikolai. If our relationship is correct, when I put in a force of 5 newtons, what am I supposed to get for extension? If my relationship is correct, what am I supposed to get for extension? According to the graph and according to the relationship you're seeing here, when force is 5 newtons, was the extension for the spring?
yeah,
2. So if my relationship is correct, Nikolai, when I plug in F as 5 and I find for E, what is E supposed to be? What is E supposed to be if it follows this relationship?
it's supposed to be 2.
Correct. Did we get 2?
Yes, sir.
Right. So this would have verified that our relationship was faithful to the condition I was given. When F is 5 newtons, E is 2 centimeters. So that's what I just proved. So I'm going to go over this one more time. Let's do a quick summary. So if 2 quantities are directly proportional, how would I write it? So let me start off. Let me write a statement. I'm going to tell you, first of all, that force is directly proportional. So force is directly proportional to extension. Okay, if I were to tell you this in the exam, you'd need to convert it to a relationship, then an equation. So how would I write that relationship? Somebody tell me, based on what you learned just now, how would I write that mathematically? Anybody? Does anybody know how you'd write that mathematically?
So would
Force it.
I heard two people just now. One of you guys, tell me.
So would it be F and then the directly proportional sign, which is like the fish without the second part, and E
Correct.
or KE?
Yeah,
Okay.
you're correct. So this is the first line, and this line directly tells person that force is directly proportional to extension. Good. Now, Sienna, we're not done yet because this is like this come like a qualitative analysis. If you understand what I mean. So like qualitative is like using adjectives. So I just saying that force is directly proportional to extension. But do you know by how much? Do you know like the exact value? Do you know the exact relationship?
No, sir.
Nah. So in the next line, I would make a quantitative statement, like given a specific relationship. So then I would say F is equal to what? I'd say F is equal to what?
F is equal to KE.
And this would directly tell me how force is related to extension. That's what it would tell me, the direct relationship. And for me to find the relationship, I would need to find for K. So typically, you could find for K. So let me tell you the ways in which you could find for K for a directly proportional question. Sometimes you will have a graph. Sometimes you will have a graph. So Sienna, wait, just stay with me, right? So sometimes you will have a graph. So Sienna, if I had a graph of force versus extension, first of all, it's directly proportional. So that graph would look like a line, right? I'm gonna know if you're with me so far.
Yes, sir.
Good. If CXC gives you a graph, if CXC gives you a graph, then how would you find for K from the graph?
You would use 2 points on the graph.
Yes, yes, perfect, perfect. And you would find the
And you would find K
by finding the we're gonna do the 2 points. You're gonna find the what?
by finding the gradient.
Yes, that is it. That is it. So sometimes you will have a graph. To find for K, um, to find for K, find a gradient. And let me explain why. When you look at the statement, F is equal to KE, right, Sienna? If you compare that to Y is equal to MX plus C, aren't you seeing that Y is F? I'm gonna be seeing that. Aren't you seeing Y is F?
Yes, sir.
And we are seeing X is.
X is E.
Are you seeing that represented here? Like F on the Y axis and E on the X axis.
Yes, sir.
And therefore, the gradient would give you what?
The gradient will give you a M, okay?
Perfect. Perfect. You have a day. You have a day. Nice. So that's one condition. Sometimes you will have a graph, and to find for K, you'll have to find for the gradient. Now, the other case, which is typical in CXC, I've only ever seen them done this once. I've only ever seen that once. The more probable case is they'll give you a condition. They will give you a condition. You're probably wondering, sir, what do you mean by a condition? So, Sienna, from the graph, didn't I give you two distinct situations? As I said, when the force is 5, the extension is 2. I said when the
2,
force
and then
is
this 10, the extension is 4.
good. So that's an example of a condition that will be faithful to our relationship. So they will give you a condition. An example could be when F is 10 newtons, the extension is 4 centimeters.
4.
Yes. So this is a more probable case. So instead of giving you a graph, they might give you one condition and they would say when F is 10 newtons, E is 4 centimeters. No problem. From here, you'd substitute the given, you substitute the values and find for K. This is a more typical case. And let me give you a quick example of this so you understand where I'm coming from. So, Nikolai Mirage, I don't know if you're there. Are you there? Can I hear Nikolai?
Are they?
Okay, so Nikolai, you're probably a little confused. So let me try to rectify the confusion. Is this part confusing you? Like when I say F is directly proportional to E and I say F is equal to KE.
Nah.
Now you understand that part?
Yeah, I understand that. But
Good. The reason why we can't leave it as F is directly proportional to E is that kind of vague. When I say F is directly proportional to E, do you know by how much? Tell me, Nikolai, if I write that statement, do you know by how much?
nah.
Nah, but if I tell you F is going to be 2.5 times extension, that's more specific. That's way more specific. And we need that. So after you put down the proportional line, you need to make an equation and you need to introduce the constant of proportionality K. The next thing you have to do, Nikolai, is actually find for K. Now, if you're given a graph of force versus extension, then to find for K, you need to find the gradient. Why? Because this is in the form of a line. I'm not sure if you're seeing it, but this is in the form y is equal to mx plus c. And when you look at it, Nikolai, y is what? What is y?
Force,
Right? And what is x?
extension,
And so what the gradient will give you? Or what the gradient give you then?
K, for the end.
Yeah, the gradient will give you
The
k.
same thing.
Yeah, the gradient will give you k, right? So that's exactly what we went and do. We took 2 points from the graph, we used the gradient formula, and we found for k. So this is a rare instance, but this will come in CXC. So if you're given a graph and they ask you to find for k, you have to find the gradient. And this was a little proof. So I just showed you guys when F is 5 newtons, extension supposed to be 2 centimeters. So if I use the relationship we came up with and I make any formula, you're supposed to get 2 on. As a matter of fact, we did get it 2, right? Cool. Now, this is a rare instance, but this is typically what CXC does. They will give you a condition. So like when F is 10 newtons, E is 4 centimeters, and they'd ask you to find for K. So Nikolai, let's try to answer this question. So the first thing I'm going to put down is our relationship. So we said F was equal to KE. Let me know if you're with me. And so I said F was equal to KE.
Yeah.
Okay, you're sure you're with me. Nikolai, you all right? You're sounding kind of like dead. Why are you sounding dead for?
Tired.
Oh, now that energy go how to come. I don't know why everybody's so quiet. Is everybody just tired? I don't
No,
know.
sir.
Yes,
Nikolai,
yeah.
you're not tired? Nikolai, you high energy?
Yeah.
All right, so let's continue, right, Nikolai? So they're telling us F is 10 newtons and E is 4 centimeters. No problem. So anywhere I see F, Nikolai, what will I replace that with? Nikolai Mirage. Anywhere I see F, I'll replace that with what?
10 newtons.
That's all. I'll replace it with 10. I don't know what K is. They're asking me to find for K. Do I know what the extension is?
Yeah. 4 centimeters.
Good. And I'm trying to find for K. If I'm trying to find for K, then K needs to be the only thing on the right-hand side. So we have K by 4. So Hannah, let me ask Hannah this. Hannah, if you wanted to find for K, then you would need to do what? Hannah, what would you have to do if you're trying to find for K like this?
You have to divide by 4.
Not by 10, right? You'd have to divide by 4. Good. Nikolai, you understand why she's saying to divide by 4? Nah, nah, nah.
Somewhat. I really do.
Not really? Okay, good. Happy that I was honest. Nia, do you understand why I would divide by 4? And I hear you much, which is sad. I want to hear. I want to hear everybody here. Nia, let me know if you understand why I would divide by 4.
Really?
Barely? Like not fully?
No, not really.
Okay, let's call that a question, right? If I tell you four doubles cost $28, how can I find for one doubles all you? Nia and Nikolai, tell me. If I tell you four doubles cost $28, how you find for one doubles?
Divide 4 by 28.
Nikolai, and you could do that too, and you could divide 28 by 4.
Yeah.
And Nikolai and Nia, until you understand that completely, and you would just, so what I'm saying is, right, if you want to find for one doubles, I would divide both sides by 4, so I would find for one doubles. So you're seeing that, right? You're seeing that. What I'm telling you is that this is the exact same position you're in. So if you know that 4k is equal to 10, how would you find for 1k? How would you find for k, Nikolai? I promise you it's the exact same condition with the doubles. Tell me.
Divided by 4.
Exactly. Because Nikolai, if you have 4 keys, k by 4, that's 4 keys, and you want to find for 1, and you would divide by 4,
Yeah.
because the 4 and the 4 would cancel off to leave you with what?
Okay.
Exactly. Nia, you sure you understand it now?
Yes,
Yeah, sure. Are you sure?
I am sure.
You say the same way I say it too. Sure. Okay. So Nikolai, what is 10 over 4? What is 10 over 4?
2.5.
2.5. So therefore, 2.5 is equal to what? 2.5 is equal to what?
Okay.
Yep, that's it. Nikolai, was it that hard? Was it that hard?
Nah, not really.
Not really, right? But you see the thing is that if all they stay quiet and all they just don't participate, I feel like you're gonna get cooked. I feel like you're gonna be real confused. So they need to talk. Hannah, let me know if you understand this other way as well. Let me know if you understand this. This is what CXC typically does. Instead of giving you a graph, they might give you a condition. You plug that in, say into your relationship you come up with, and you find for key. Let me know if you understand this, Hannah.
Yes, sir.
Yeah, sure.
Yes, sir.
Okay, I'm gonna do a little checklist. From 5 people, all you understand this? Kelani, you understand this? Like when you're doing directly proportional questions. And this way this do like CXC would typically give you a condition. They would give you a condition, you'd plug in the condition, and you'd find for key. Can I hear and Kelani? What about the rest of the other form 5 people? Form 5 people. I'm only if all you understand this.
Yes, sir.
Tough crowd today, boy. Tough crowd. Kelly, you understand everything or not?
Yes, sir, I understand.
So Kelly, over here, what did I do? Let me see if you understand. What do some of us? What do over there? What did I do?
Okay.
Yeah,
Okay,
please.
so we understand. Okay, so we understand from the equation like prior that F is equal to KE. So is the force and the extension. So we're gonna take that and we don't know the value for K, right? But we have the value for force and extension,
Yeah,
and we want to find for K. So we find it for one basically. So we're gonna take the force and divide it by the extension, and that's how we'll get the value for K.
that's brilliant. Yeah, we have it. We have it. And it makes sense because Keely, constant of proportionality, key. And it makes sense. Keely and key.
Yes.
Yeah. And
Yeah.
let me know if you understand this too. Like where they would give you a graph and you would have to find a gradient to find the key. You understand that as
Yes,
well?
sir, I understand. Yeah, you just take out the point from the graph and yeah, do the gradient for the line, and well, yeah.
Great. Okay. You see, like when I talk to man, I just feel like all they understand, but like when I quiet and sing, that already doesn't know what's be happening. And then after class, you go tell your parents, I don't understand anything in that man class, but you never tell me I didn't understand. Or you had to tell me if you're confused. Because I will go over it as much times as you need me to for you to understand. I will. So these are the major situations you would have in the exam. Either they give you a graph or they give you a condition. This one is more probable. That's what they typically do. Let me see how versed you guys are. Do you all think directly proportional and proportional means the same thing? Yeah or no? Somebody tell me. Do you guys think directly proportional and proportional means the same thing? Akira, do you think that directly proportional and proportional means the same thing? Can I hear an Akira? Um, Keely, do you think that directly proportional and proportional means the same thing? You can take a guess.
Um, no, I don't know, sir. I don't.
That's not a problem.
So,
Nikolai, see Akira.
yes.
Right? Nah, not quite. There's like one distinction. See if I could figure it out. So directly proportional versus proportional. Like people typically say they're the same thing, but they're slightly different. Like people will say there's the exact same thing, but like there's one small distinction. Anybody figure it out? Guys? Nikolai, McLeod, do you know the difference between directly proportional and proportional?
Directly proportional and proportional.
Yeah, there's a very slight difference. There's a slight difference.
Well, the word direct proportional, it directly like it equal.
Nah, that's not good enough. Like I need it to be like more precise.
Okay, so directly means, well, for a straight line. Okay, so like you have a square and you put a straight line through. It cuts in this square half and half. So it's like one side is equal to the other side.
Wait, you say one side is equal to the other side. Um, and a square. What do you mean by the square?
Okay, so like a square and you put a line through, like you cut it in half.
I think
Okay,
it is.
just let me think.
I think you're describing something like y is equal to x, where the line is like a diagonal line. But that doesn't always have to be the case. Like this graph could look like this if I wanted. It could look like that. Could look like that, and it'll still be directly proportional. You know what? Let me give one another graph, right? Okay, which one will be directly proportional there? Graph one or graph two?
Graph one.
Yeah, graph one. Was it earlier? What's the difference between graph one and graph two?
The line passing through the origin in graph one, but in not in graph two.
Exactly. That is it. So when we talk about directly proportional relationships, so when we talk about directly proportional, what makes it directly proportional is the fact that the line is going to pass through the origin. Physics, people that do physics in gas laws, and you have to know the reason, and you have to know how they came up with the Kelvin scale. People are doing physics, but they know what I'm talking about with the Kelvin scale.
Yes, sir.
And like you would have something like V versus T. And if you use degrees Celsius and you draw your graph, wouldn't the graph look like that?
Yes, sir.
And I'm talking to physics people here, and then what they figured out is that if you extrapolate the graph, it would cut the graph at minus 273 degrees Celsius. Now, the reason why we can't use this for the gas laws is because that is not directly proportional. For a graph to be directly proportional, it needs to be starting at the origin. So if you didn't know, now you know, physics people. That is why the Kelvin scale was made, because if you use degrees Celsius, it's not going to be directly proportional. You're going to end up with a graph that does not pass through the origin. But if you were to quote unquote start at minus 273 and you were to shift your graph, then would that be directly proportional now? So we'd consider the 0 Kelvin. Would that be directly proportional now? Look at our tab.
Yes, sir.
Because directly proportional means that your graph is passing through 0, 0. And you know, 0 Kelvin is defined as minus 273 degrees Celsius. That is what it's defined as. So directly proportional means that the line passes through. Nikolai, did you know that before? That directly proportional is when it's strictly passing through the origin.
Well, I can explain it like that, but I try to explain it using the square method I told you about just now.
Okay, when you say square method, you mean like you draw a square and like the line would be like that? That's what you mean?
Yes, sir. Yes, sir.
But you see, the thing is, right? I could apply that square method, and the graph doesn't necessarily have to start at 0, 0. Heck, my graph could start anywhere. Watch. My graph could start over here. And if you draw a square, that doesn't mean it starts at the origin. So you gotta be careful. So when I say directly proportional, it means that the line passes through the origin. So, Kaylee, in this situation, the y-intercept would be what? What would the y-intercept be? If a line passes through the origin, guys, what do you all think the y-intercept would be? Somebody in class, if a line passes through the origin, then it passes through the what y value? Check it out over here. So this line over here passes through 0,
0.
0.
0?
Yes, because okay, it cuts both the x and the y-axis at 0. So the x-intercept is 0 and the y-intercept is 0. So the y-intercept is going to be 0. Cool. Now, could anybody tell me what proportional means? So you know that directly proportional means that it has to pass through the origin. Now, two things could be proportional, but if it does not start from 0, 0, then it's not directly proportional. That's like the key difference. That's the key difference. It's So in this case, the y-intercept would be some non-zero value. It'd be some value other than 0. It'd be some value other than 0. Keely, you understand what I mean? Because if it's not passing through the origin, any y-intercept would have to be some other value other than 0.
Yes, sir.
You're sure you understand that? Like if I tell it not passing through the origin, and that would mean like it passing
Yes.
through some other value.
Yes, sir. Yeah. Because the origin is 0, so
Correct. So like if it starts like okay, if your relationship starts over here, then the y-intercept will be what?
it'll be 10.
Yeah, 10. So that would mean directly proportional. So
It'll just be
like
proportional.
correct. Correct. Yeah. So here what? I could soak in the notes. This is the example I gave you for Hooke's law. And the two cases are over here. These are the two cases. Sometimes it will give you a graph and you'll have to find for the gradient to find for K. Or sometimes it'll just give you one condition and you'll have to plug in the condition to find for K. I'm going to give you all some questions now. Let me come up with some questions real quick. Camille, let me know if you're there. All right, so Camille, this was one of the topics that we did not get to finish in the crash course. So it's good that we're doing it today because I'm killing two birds with one stone. I mean, two birds with one stone. So Camille, if you don't understand anything, please tell me along the way. All right, so take any notes, guys. Take any notes. One moment. Let me do a quick checklist. I mean, I'll roll call quickly. Akira, do you understand everything so far?
Yes, sir.
Are you certain that you understand everything so far?
Yes, sir.
I trust in you, no? I'm trusting you. I'm trusting you. Camille, do you understand everything that's happening so far? Or no?
So to be honest, I was here, but I was in and out.
Okay, no problem. But Camille, the basic concept is that if one quantity increases, the other one would increase. That's what directly proportional means. But you need to figure out by how much. So that's where the constant of proportionality K comes into play. You'll see what you would do when you do some questions. We're gonna do some questions right now. Hannah, do you understand everything so far?
Yes, sir, but you could just explain the difference between proportional and directly proportional again, please.
No problem. Let me just put the questions on the screen. Right. All right. So, Hannah, I'm going to give you two graphs over here. Let's just say this is force, and this is the length of the spring, right? So this is the length of the spring. And then I'm going to give you a graph of force versus extension. So force versus extension. If you had to say, Hannah, which one looks directly proportional? Like just guess, take a guess. If you had to say which one,
Force versus extension.
I would say so as well. Because if you look at the graph of force versus length, does it start at 0, 0?
No, sir.
No, no. So long story short, it's directly proportional if the graph passes through 0, 0. Because that would have meant that when one quantity is 0, the other one is.
0.
But in a situation like this, when the force, okay, when the force is 0, you would still have some length. Let me see if I give you an example. Like, okay, let me call this 9, right? And let me just change up this graph quickly. Okay, so I changed up the graph quickly, right? So, Hannah, do you understand that for this graph? When the force is 0, so is the extension. The extension is also 0.
Yes, sir.
But like in this graph, if I give you this, if I tell it as 9, right? Here what? Like read off that point for me. Read off this point for me. If you were to read off that point, what would it be?
0, 9.
0, 9. And it would tell you that when the force is 0, the length is
9.
yeah. Does that look directly proportional to you? So we're starting off with force is 0 and the length is 9. Does that look directly proportional?
No, sir.
Nah, but this clearly looks directly proportional because when you look at that and just seeing that both of them starting off at the same point, really, when F is 0, E is 0.
Yes, sir.
No, don't get me wrong. This is proportional, but it's just not directly proportional because when F is 0, length is not 0. Keely, you understand the difference, right?
Yes, sir.
Okay. All right. Keely, Christian, do you guys understand or no?
Yes, sir, I understand.
All right. Christian, when we do
Yes,
the
sir.
questions, I'll see if you understand, right? Nia and Nikolai. Nia and Nikolai, let me know if you understand.
Yes, sir.
Okay. All right. Nikolai McLeod, do you understand everything that was went through thus far?
Yes, sir.
Okay. Um, Nikolai Mirage, do you understand everything that was discussed so far?
Yeah.
Yeah, don't worry. When we doing questions, I'll make sure you understand, okay? Ria and Samir, are you all okay?
Yes, sir.
Yes,
All right. Serena, oh, Serena, I feel like I know you okay, but tell me anyways.
Yes, sir. Yes, sir, I
Serena,
understand.
you okay and thing otherwise, like out of school and thing, other than school, like you good?
Yes, sir.
Okay, good. Happy to hear that you're good. You're not like killing yourself for too much work, right?
No, sir.
Okay, good, good. Because I know you're very studious. Sienna and Vani, are you all okay?
Yes.
Yes, sir.
Okay, good. Well, let's do a bunch of questions then. Right, so to do the first question, I'm going to call Ria. Ria's gonna help me with the first question. Yeah, big up yourself, Ria. One time. Don't know. Andrea, big up yourself.
Uh-huh.
Yeah, yeah. So Ria, read question 1 for me.
Um, why? I can't really see good. So I'm sorry. That's a why, right?
Yeah, that's our why.
Right. Y is directly proportional to x. When x equals 4, y equals 10. Find the constant of proportionality k and find the value of y when x is 7.
Right, so first things first, which kind of situation is this? Is it the situation that they give you the graph, or is it a situation where they give you a condition?
The condition.
Yeah, it's a condition. First thing we have to do, right, Ria? We need to convert the statement into like an expression, into like a mathematical expression. So I would say that y is what?
Y is equals to 10.
Nah, nah, nah. Mm-mm. So when you read the statement, right, what are they saying?
Y is directly oh. So you could put y is the sign for directly proportional to x.
Right? And what's the next sign gonna look like?
Uh, y is equals to ke.
Nah. In the last question, it was F and it was E. Those were the units slash quantities. In this
Y
question,
equals to x. Y equals
y is equal to kx. Yeah,
ki. Okay.
good. So we have y is equal to kx. In the first part, they want us to what?
The find the constant of proportionality k.
Talk to more. I feel we could do that. How do you think we could do that?
This is where we switch in the values.
Switching values. Not quite. So okay, Ria, let's think about it logically. They want us to find for what?
K.
Right. So if we want to find for something in maths, then you have to make an equation where that is the only unknown. Right now, when you look at this, is K the only unknown?
No.
Nah. Where's the other things you don't know?
Y and x.
But you actually do know what y and x is because they give you a condition. What was the condition?
Right. X is 4 and y is 10.
Yeah, that's a condition. So what is it we really don't know for then? If we have a value for x and have a value for y, what is the one thing we don't know? What's the one thing we don't know?
K.
K is the one
K.
thing we don't know. So what would I do next? You could do
I
it.
don't know.
All right, so Ria, like I said, to solve any equation, you need to make an equation with one unknown. So what are they asking you to find for in part one?
K.
They're asking you to find for k. Do you have an equation that has k in it?
Yeah.
What's that equation we have to have k in it?
Y equals to kx.
And when you look at this, you're saying three unknowns, right? You're saying y, k, and x, but do we know what y and x is?
Yeah.
So is there a way I could use the information given to make an equation like k is the only unknown?
Uh-huh.
No, I'm asking you,
Um,
is there a way I could use the information they gave me?
yeah.
Right, then tell me what I would write then. Talk to me. Tell me what I would write. You could do this. You could do it. Everything is right here that I need.
Um, oh God.
So Ria, we need to solve for what? What do we need to solve for in part one?
K.
Right, so we need to make an equation for K, where K is the only unknown. Number one, do we have an equation with K?
Yeah.
And
Y equals kx.
good. But right now there's three unknowns there. But do we know what X and Y is?
Yeah.
So how could I use that
So
information? Tell me.
we could put 10 equals
Right.
um
Good. 10 is
10
equal.
equals to k open brackets 4.
Right. And we're trying to find for what here?
K.
So if we're trying to find
So
for
we
what?
divide by 4. We
Yes.
divide everybody by 4.
Divide everybody by 4. You get divided by 4, you get divided by 4. So K would be equal
Yep.
to what?
Two and a half, eh?
Yeah, 2.5. So if K is equal to 2.5, then we just answer part one. That was it. That was easy or hard?
So long I take to do that? Oh my god, that's embarrassing.
No, it's fine. You're learning. You're learning, right? Because I trust that you'll be able to do question two in record time. So it's not a problem.
I'll try my best to.
So we know that K is 2.5. So if I ask you to write the final relationship, what do you tell me? What is the final relationship? Y is equal to what?
Um 2.5 k
Now, so
or x.
yes, because our relationship was Y is equal to KX, but we needed to find for K. So now that we know what K is, I
Right,
can say
so
Y is equal to 2.5x. I'm wondering if you're okay.
yeah, I think I'm just mixing up my letters.
Maybe. So let me do question two now. It wants us to find the value of Y. Find the value of Y when X is.
7.
So we don't know what Y is, but they want us to find. Okay, so we don't know what Y is, but they're telling us that X is equal to 7. Now, is there a relationship we have for Y and X?
Yeah.
Yeah. How is Y related to X? Y is equal to what? Tell me. Oh, remind me. Y is equal to what?
Y is equals to 2.5 x.
Yeah, so whatever X is, Y is going to be 2.5 times X. So tell me, how would I find for Y then? If they're telling me X is 7, how am I going to find for Y?
Is it 7 by 2.5?
Yep, 2.5 by 7. That's correct. What would you get?
17 and a half.
17 and a half?
Mm-hmm.
Pick any word fits. Yeah. All right. Cool. So Ria, you feeling
Right,
okay?
that's it?
That's it. That's it. That's literally it.
Oh, okay.
But a
That
lot of,
wasn't too bad.
it wasn't too bad, right? A lot of things in maths look intimidating, but very simple. You just need to know where you're starting from. So now I'm going to call upon, well, here what we had. I want you to do one more to make sure that you fully master this thing.
Okay, sir.
So after you, I want Nikolai Mirage to help me with the other question. So I call him out one time. So Nikolai, you go help me with the other question. Right, Ria, so you okay with one, right?
Yes, sir.
Bet. Now we look at number two now. Don't worry, Nia. I'll give you a question too, just to make sure you understand. So Nia, Nikolai, and Christian. I'll give you all a question just now. Yes, so Ria, read question two for me.
Um, so you could zoom in a bit. M is directly proportional to n, given that m equals 15 when n equals 3. Find m when n equals to 8.
So this might seem a bit more complicated, but I assure you, it is the exact same kind of steps. I promise you. So they're
Okay.
telling you m is proportional to n. What is the next step? What do you typically do?
M equals to n.
Nah, you can't say m is equal to n.
M equals to kn.
Right. You need to know how much. You need to know how n is related to m. So like m is how much times n in a sense. You need to know a specific value for k. So m is equal to kn.
Okay.
Right. What would you do next?
We finding for no, we're not finding for k.
Well, let me ask that question. Can you answer the question? Can you answer the question without knowing for k?
No, I don't think so. I think we gotta find for k first.
Yes. And everybody pay attention, right, Ria? Let me look at the logic behind it. As it is right now, right, Ria? As it is right now. If you go to find for m, that'll be m is equal to k by 8. So m is equal to 8k. Is that a numerical answer? 8k. Is that a numerical or algebraic answer?
Algebraic?
Yeah, but we want numerical answer. So for us to figure out what m would be equal to, we need to find for what here? Or what are we still missing?
We gotta find for k.
Gotta find for k. Yeah. So did they give us any information to find for k?
Yeah, we have m equals to 15
And
and n equals to 3.
good. So I could use that to find for k.
So is 15 equals to k open brackets 3,
Right? And
and then
define
we divide everybody by 3.
and k would be?
K will be 5.
So if I know k is 5, what is my complete relationship? What is my relationship here?
K is equals to no.
Asking is for relationship, the full relationship.
Uh, I got lost.
All right, so let's start back, right? So they said m was what?
M is directly proportional to n.
But like, okay, saying that is one thing, but I need to know how they're related, right? I need to know exactly how they're related. So then I would say m is equal to k by n. So that's how they're exactly related. But do I know what k is? Do I know what k is?
Yeah.
Well, now I know what k is. So if I wanted to write the complete relationship, what would I write?
M is equals to 15n.
They say 15n. Nah.
5n. 5n. Sorry.
So what does this mean in English, Ria? Well, this means that m is just what? M is just going to be what?
Um,
M is equal to what? What is m equal to?
5n.
Right. So whatever n is, m is going to be 5 times that. So that's the exact relationship. You understand what I mean? That's like the exact relationship. Like, okay,
Okay.
you can't really figure out anything from this, right? But if I tell you that m is 5 times n, and if you know what n is, you could find for m.
Yeah.
If I tell you n is 1, where's m? If I tell you that n is 1, what would m be?
1.
Now, remember, m is 5
Wait.
times m is 5 times n. So if I tell you that n is 1, what m would be?
5.
5. If I tell you n is 3, what would m be?
15.
Good, because whatever m, okay, m is literally just 5 times n. That's like the exact relationship. You understand what I mean? So like whatever n is, to find for m, you just multiply that by 5. So this is the direct relationship. This is the relation that's telling us how m is related to n. So m is just 5 times n. You sure you think you understand now? No.
Yeah, I understand.
So this is the exact relationship between m and n. So then they're saying find for m when n is equal to 8. So how am I going to do that? So they're telling us when n is equal to 8. So how am I going to find for m?
Um,
Tell Maria, how is m related to n?
we, we multiply in 8 by 15.
8 by 15? Nah.
Or 5.
Wait, yeah. So remind me, how is m related to n? What's the relationship between m and n?
M is 5 times of what is n?
Exactly. And n is?
5.
Nah, n is 8. N is 8. They're telling us that n is 8. So that would be 5 times,
8.
right? Because m is just 5 times whatever n is. So if n is 8, m would be 5 by 8. So 5 by 8 is?
40.
That's the answer. But like I wanna make sure that you understand it like logically. Like according to our relationship here, whatever n is, m is just gonna be how much times that?
5 times. Well, how much times n is?
Right? So m is just 5 times n. It's always 5 times n. So if I tell you n is 8, then m would just be 5 times that, 40. You feel like you understand?
Oh, yeah. Yeah, I understand.
So like, okay, if I tell you n was equal to 3, how I find the answer one time?
You multiply n by 5.
Right? And that'll be 15, right? If I tell you n was 10, what is m?
50.
Yeah. You see, that is the thing. So Ria, all we're trying to do is we're trying to figure out the exact relationship between M and N. So like, how are they exactly related? Over here, I don't really know. But when I find for K, I could clearly see that M is just 5 times N. So that kind of linking M to N. You understand what I mean?
Yeah.
Okay, good. And it was the same thing in this question, Y is just how much times X? Y is just how much times X?
2.5.
Exactly. So whatever X is, Y would be 2.5 times that. That's all. If you like, you understand it.
Yeah.
Now, I feel like it has so much people in class that they just get distracted and they miss that juicy piece of information. But that's fine. We do more questions. Yeah. Right. So Nikolai, you're gonna help me with question 3. So unmute and let me run the thing. I run it.
Yeah.
So Nikolai, again, going into this, I want you to understand that all of these things seem harder than they actually are. Like you saw in this example, right, Nikolai? M is just what? Whatever. M is just what? According to this relationship here, M is just what?
There's a good question. M equal to 5.
Exactly. So like all I'm saying, right, Nikolai, is that whatever n is, m is gonna be 5 times that. That's all. So like if I tell you n is 3, M would just be 5 times 3. If I tell you N is 6, what would M be?
30.
Exactly. So, Nikolai, this is all we're trying to do, you know. We're just trying to see how one thing is related to the other thing. That is all. And that's the whole concept of this. In the first question, it was the exact same thing. Y is equal to how much times X? 2.5 times X. So you're trying to find a relationship between two quantities. That's the whole concept here. That's literally it. It's not that hard. All right, so Nikolai, let me look at question 3. So could you tell me what this means in English?
That y is directly proportional to x.
Good. Y is directly proportional to X. Now, in the question, they are giving you a what? Or what I call that? That's what C. That's our what?
A connection.
A condition. Now, Nikolai, what if I told you you could look at that and see the answer? You could be like, seriously?
Yeah.
Well, let me ask that question, right, Nikolai? Y is 18 and X is?
Right.
What is X?
6. 6.
What would I have to do with 6 to get 18?
Multiply by 3.
And what if I tell you that was the answer? What if I told you Y is equal to 3X? You tell me, wow, that's really easy. And?
Yeah.
Because it
That's
is
really
really
easy.
easy. All you see in that? Let me know if all you see in that. Like, okay, they tell them Y is 18, right? And they tell them X is 6. If that is the case, how is X related to Y then? Or what I need to do with 6 to get 18? Or tell me. Or what I need to do with 6 to get 18?
Multiply by 3.
That is all. That is all. So Nikolai, my relation my equation would just be Y is equal to 3X because whatever X is, I'll multiply by 3 to get Y. But I need to show you the full working now. I have a feeling that nobody paying attention and it's just you and me. But that's okay. Probably paying attention.
So I hear
Look at Nikolai.
Well, I'm paying attention.
Okay.
So I pay attention too soon.
Yes, type in.
Okay. When you look at this, right? When you look at this, forget about the complicated maths and thing. This is just logic over here. When you look at this, how is X and Y related? What would you have to do with X to get Y? Forget about the complicated maths. What would I need to do with 6 to get 18? Somebody else, Nikolai.
Multiply.
Multiply.
Multiply by 3, sir.
That is all. So Y is just going to be how much times X?
3 times X
That is
or
all.
3X.
That is all. This is a very simple topic, you know. A very simple topic. Now, Nikolai, we need to do the full working for that though. We can't just write that down, although that is correct. So Nikolai, let's write down the full working for that. So they're telling us Y is directly proportional to X. And in the first question, they want us to find the equation connecting Y and X. So Nikolai, can't we just find out Y is equal to 3X?
Yeah.
And that linking Y to X?
Yeah, that linking y to x.
But we need to do the full working, right? So the full working would look like this. So Y would have to be equal to some number multiplied by X. So that's why it is say Y is equal to KX. That's why the next step is this. So Nikolai, if two things are directly proportional, then it would always be in this form. It'd always be Y is equal to some number multiplied by X. And your goal is to find for K. That's your goal. Your goal is to find for K. You with me so far or confused?
Nah, which I would say
Right. So what was the condition they gave me? What was the condition they gave me?
16 and 9, 16, 18 and 6.
18 and 6. So they tell them Y is equal to 18 when X is equal to what?
6.
So I need to find for K now. To find for K, what do I need to do with this information?
Yeah, that's a good question.
Like real simple, but real simple. Real simple. And you can see that the answer is 3. And you can see that the answer is 3, right? Like you
Yeah.
can look at it and see the answer is 3. Now you tell me, what would
Divide
you have to
18
do
by
with, say that again?
divide 18 by 6.
Yes, but you need to put that into the equation and show them the full working. So, Nikolai, you know that y is 18 and you know that x is what?
Say that again?
Right, so you know that y is 18 and you know that x is what?
6.
Good. So you could plug that into this and get your answer. So anywhere I see y, I could write 18. I don't know what k is. We're trying to figure out what k is. And we know that x is what? What do we know x is, Nikolai?
6.
Right. If I'm trying to find for k, what would I need to do?
Divide everything by 6.
That's all. Divide everything by 6. That's it. So k is equal to what?
3.
That's all. And so we could say, we could write the equation, all right? The equation will be y is equal to what?
Y is equal to 3x.
That's it. That's literally it. You feel like you understand that fully?
Yeah, more than fully.
Good. Let's do number 2 now. Read number 2 for me.
Value of x when y equal to 30.
Ah. So they want me to find the value of x when y is equal to.
30.
So now I have to use this relationship to find for x. So what do you think I'm gonna do? What do you think my first step is?
So we divide 30 by 3.
That's it, you know? Yeah. See the answer. You saw it in your head. You saw it. You saw the answer. That's correct. And that's really good that you could see that. Now we need to play that on paper. But brilliant. Let's see what you just did, right? They're asking us to find the value of x when y is 30. Now we know that y is just 3 times x. So and when x is 10, you'll get 30. And so like you see that, like logically, when x is 10, y would be 30.
Yes, sir.
But again, you need to put down our working on paper. So Nikolai, let's try to do that. So Nikolai, what do we know y is?
Y is 30.
Exactly. So anywhere I see y, I'm going to write what instead.
30.
And 30 will be equal to 3x. So to find for x, what do I do next?
Divide everything by 3.
Divide everything by 3. So x is equal to,
10.
and Nikolai, that make perfect sense, right? Because n when x is 10, 3 by 10 would give us back 30.
Yeah.
Yeah. So I think you understand. I think you understand. I feel like you just have a hard time converting the intuition to like working on paper. But you understand it, you know, you just have a hard time writing it on paper. That's what's happened.
Yeah, that will be happen.
But it's something you could work on. It's something you could achieve. The main thing is that you understand the concept and you just have to practice and you'll get through. So that's essentially it for directly proportional. All we need to look at is inversely proportional. Give me a second, right? Okay. Nia, you there?
Yes.
You sure? Are you really understanding everything that happened so far or not?
Yeah, I am.
Yeah, sure.
Yes.
Taking your word for it, you know, because we're going to do a question now. I'm going to see if you really understand.
Mm.
You can't escape, you know. None of you guys
Mm.
can. Once you're in this class, I will make sure you understand. You really can't escape. But, you know, to become a butterfly and spread your wings, you need to come out of your comfort zone. You need to come out of the cocoon. So, it's all part of it. Question 4. All right, question 4. Neil, let's walk through it. So give the question I read for me.
Y varies directly as x given that y equals 12 when x equals 3. Find the equation connecting y and x to the value of y when x equals 9.
Right. So they want me to form an equation. Do you have any idea as to how to start off? Talk to me.
Well, you'll have to say the y and the sign x,
Yeah, you're going good so far.
and you have y equals kx.
I have a question, right? You think you could look at it and see the answer?
Yeah,
What do you think the answer is? What do I have to do with 3 to get 12?
divided by 3 and you'll get, oh no, you have to say 3 by 4 and you'll get 12.
Yeah, so what do you think K is? Before even doing any maths, what do you think K is?
4.
K is 4. That's it. Real
4.
simple, you know.
Mhm.
But we just had to prove that mathematically.
Yeah.
So they're telling us y is equal to 12 and x is equal to 3. So what we're going to do next?
Mm, yeah, moving on to the next question now.
Now we are finished yet, you know. We need to find for K.
Oh,
We need to mathematically find for K. So we figure out that y was
okay.
equal to kx. And we have the information y is 12 and x is 3. How could I use that to find for K? You tell me.
Okay, so you can repeat that.
All right. So you're okay with y is equal to kx, right? You're okay with that part.
Mm-hmm. Yeah,
And now you need to find for what? So if you want to, and you told me the answer was 4.
yeah.
But
Oh,
you had to show that working. How we gonna find out?
yeah.
Gonna find
Okay.
K.
So you have to say, you have to replace the y with 12
Mm-hmm.
that equals to k and in brackets 3.
Yeah,
Okay, and then you'll divide the two of those by 3, which will give you 4.
that's it. Yeah. And so the full equation, so the equation connecting y and x would really be what?
Y equals 4x.
Earlier, let me know if you understand. Now, it's all you can see that with all your own eyes. Because watch, when x is 3, right? And y is just 4 times 3. Let's see now, no.
Yes, sir.
Yes, sir.
So it makes sense. It makes logical sense because when y is 12, x is 3. So k would have to be 4 because 4 by 3 is 12. So I hope we can see the intuition, the logic behind it. That's the most important thing. Right? So Nia, let's move on to 2 now. What are they asking of us in 2?
The value of y when x equals 9.
The value of y when x is 9.
So,
Talk to me. How are we doing that?
so I would put, yeah, that and x equals 9. And then you'll say 9 divided by 3
Nah. Mm-mm. So,
multiplied by 3.
nah.
I mean
Wait,
4. Oops.
nah, no division. So, tell me here.
Multiplication.
Wait, don't stop guessing. Stop guessing. Let me look at it logically. With these types of questions, the second question uses the first part. So, Nia, what is the relationship
Mm-hmm.
between y and x? What's the relationship between y and x? Remind me, what is the relationship between y and x? How is y related to x?
Hmm.
It's much simpler than I could ever think it. Real simple. Well, what do I need to do with x to get y?
Best friend, get your hair cut, best friend.
Remind me, what is the relationship between y and x? How is y related to x? How is y related to x? How is y related to y? How is y related to x? 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 How Nia?
Yeah.
Yeah. What would I need to do with x to get y? So like look at this example here, right? X is 3 and y is 12. What do we do to x to get y?
We multiply by 4.
Right. And so the relationship we came up with, wait. So what was the relationship we came up with then to link y to x?
4x.
So what does this tell me? This tells me that the y value would just be what?
4x.
Right. So whatever x is, the y value would just be 4 times that. Do you really understand that? You sure you understand that?
Yeah.
So like, let me ask that question, right? If x was 3, or y go be?
Y would be. Y would be.
All right, so that I mean you don't fully understand it, which is fine. You're gonna understand it after today. So again, it a lot simpler than you think. So what's in Ria? Nia. To find for y, we figured out that y is just how much times x. Y is just how much times x?
4.
It's just 4 times x. So if I tell you x is 3, then using that relationship, we know that y should be what?
12.
Yeah, because the relationship says that the y value is going to be 4 times the x value. If I tell you x is 7, what would y be?
4 by 7.
That is all. That is all. I tell you it was simple. And so Nia, in the second part is they're asking us to find the value of y when x is 9. So remind me, how is y and x linked together? How are they related to each other?
You'll have.
Is you gotta do any new work in it? You see, is like from part 1. Remind me, Nia, how is y and x related to each other? All right, next question. Other question, right? When I say that, I'm probably confusing the end. You're probably saying, well, what does Sir mean by y related to x or something? You're probably confused by that. So let me try to demystify that. You see this equation over here?
Mm-hmm.
It tells us what y would be in terms of what?
X.
Yes. So you would say that this equation links the y value to the
X.
yes, because all I had to do is put in an x value and that would give me the y value. So when I ask for an
Mm-hmm.
equation linking y to x, this is what I mean. So this is the equation telling us what y would be in terms of x. So, and you know for yourself that y is just what? Y is just what?
X.
Now, y is not x. Y is how much times x?
Oh, 4 times X.
Right. And in this question, they want us to find the value of y when x is 9. So how are we doing that?
You'll have to say 4 by 9.
That is all because y is just 4 times x. Yeah. Understand?
So, yeah, but for the last equation you're doing, I get a little confused because you divided, and I wasn't too sure, like, why you divide.
No problem. So in the last one, they wanted us to find the value of x when y was 30. So let's look at the relationship we came up with. I'm going to erase it, right? We got y is equal to 3x. Now, in this question, they
Mm-hmm.
wanted us to find the value of x of y.
X.
You see, if they was asking us to find the value for y, we just multiply. But this time, they wanted us to find the
Mm-hmm.
value of x. So think about it logically, Nia. Let's think about it logically first. So the relationship is y is equal to 3x. What does that mean in English, Ria? I mean, Nia. It means that y would just be how much times x? Y is how much
3
times x?
times X.
Right.
3
So,
times X.
And they're telling me that y is 30. Y is 30. So what would I need to multiply by 3 to get 30?
10.
So I would have to do what by 30 to get 10? Multiply by 3 or divide by 3?
You'll have to divide 30 by 3 to get 10.
Exactly. Because it was asking me for x and not y. Right? So check it out. Check it out. They want us to find the value of x when y is 30. So they are telling me up front that the y value is 30. Now, I don't know what x is. I don't know what x is. So to find for x, what would I do next? I want to find for x.
Divided by, you have to divide the 2 by 3. The both of them by 3.
And x will be equal to?
10.
And that makes sense because they were asking me for the value of x when y is 30. So when x is 10, right? When x is 10, what would y be?
30.
Bam. But in this question, they were asking me for the value of y. And this was really simple because we just had to use the relationship. Y is equal to 4x, which means that to find for y is just 4 times x. Wherever x is, you multiply by 4 and you get your answer. You sure you understand?
Okay. Yeah, I understand better now. Because I kind of threw off a little bit when he was doing the division. I didn't really grasp it.
Is that a good thing I called on you?
Yeah.
You probably would not tell me it was confusing. You see, this is the thing, eh? This is the thing. If all they want to actually understand and become really good at math, they had to tell them all they're confused or they can't stay quiet. But if you stay quiet, then you're not going to improve. So, like, you sure you understand?
Yeah, I understand better.
Right. So, I have a question, right? I'm going to add in an additional question here just to make sure you actually understand. Because you know me, I'm a trust issues. Um, mm, oh, Form 5 people, we're going to start just now. Find the value of x when y was 300. So Nia, let's try to do the additional question I gave. So question 3, find the value of x when y is 300. So walk me through how you would do that.
So, well, we'll start off with putting the x equals, well, just a visual, x equals question mark and y will be equal to 300. So then you'll have to divide that by 4.
Yes, that's correct. Well, we had already working, right? So to put on the working, we're gonna say 300 is equal to what?
300 is equal to,
Remember the equation. So in all the questions, you have to use the equation you came up with. So we know y is 300, so I'll say 300 is equal to what?
4. 300 is equal to 4.
For what? Yeah, let's tell me. For what?
4x.
All right. And to find for x, what I go do?
You'll put the both of them over 4, divided by 4.
And 300 over 4 is?
Next, 75.
Okay, I feel confident now. I feel like you understand it. That's good. Yeah. You feeling good?
Yeah, I feel I'm better.
That's extravagant news. I'm happy to hear that. I'm happy to hear that you understand. So it looks complicated, but it's actually really simple. It's very simple. Nikolai, I know that you would have been confused last class. You feel like you understand a bit more in this class?
Yes, sir.
Yeah, sure.
Yeah, sure.
Okay. I take any word for that. I take any word for it, I take any word for it. And again, if all you
We have two
confused,
nickel.
you have to Nikolai's. You know that
Oh my
Spider-Man.
gosh.
You know that Spider-Man meme? We need one more Nikolai. We need
Oh
one.
yeah.
Yeah. But again, all you know how to bite, right? I have big teeth and thing, but I don't bite nobody, you know. If all you don't understand something, all I could just tell me. All I could literally just tell me at any point in time. I will go over it. So people in the Form 4 class, all they understand everything we do today or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Okay, now before I leave, I'm gonna give all the homework, you know. So I don't know all they have homework. Don't come next class and say we didn't have no homework, eh? I tell you all they know we have homework. And by the way, all the recordings are posted. Sometimes I don't tell you it's posted, but all you have to do is just click the link in the group description and you'll find all the recordings. It's there. It's there. That goes for the people that are doing the crash course as well. Day 5 was uploaded. It's in the playlist. You just go and press the link and you'll see the recording. I send the notes as well. So this is the homework. And I'm telling all of this. You could say you understand how much. Until you actually practice, you will never understand. Like Romano, you see that question, you said, no? You ask me why you're using that point.
Yeah.
I explained that a billion times in class. But you see, it's only when you do the question, you realize why it's important. Like you ask yourself why. I could say it a billion times in class, you know. But I'll just gonna shrug. I'll gonna be like, yeah, I understand. But it's only when you do the question, you go take your question. It's only when you do the question. So do the question now. Do the question. I'm gonna put a violin sticker here. Do the question. So all you can't say it in our homework. As a matter of fact, somebody take a screenshot of this and put it in the form for a group chat. Do that for me. Do that for me. I trust someone all you. Do it fast. Take a screenshot of this and put it in the form for a group chat. Good. Do the homework. Thank you, Romano. So form 4 people all they could disperse. If all they want to stay for the form 5 session, you all can, right? Or if not, you could disperse. I'm gonna stop the recording.